Hello, welcome back to the channel. So let's continue our previous video and solve for the second part of this question over here. So what you'll see afterwards will be the solution to the second part over here, since we divided this question into two parts over here. So for the largest interval, we have to first check where our y function is not defined, right? That is exactly how we will be able to identify those breakpoints and then further observe about the largest interval for which our y function is always defined. So you can clearly notice that for our y function to be not defined, our denominator should be equal to 0, right? And in this case, you can clearly notice that for our y function to be always defined, our denominator should never be equal to 0. So 2 minus e to the power 1 minus cos x should never be equal to 0. Sorry. If this expression is never equal to 0, this means e to the power 1 minus cos x is never equal to 2. If we take the ln on both sides, it means 1 minus cos x is never equal to ln 2. And this means that cos x is never equal to 1 minus ln 2 in this case, right? So if your cos x is never equal to 1 minus ln 2, we can sketch both of these functions on one graph. So if we sketch the function of cos x, you know that the cos x function looks like this. If we sketch y equals 1 minus ln 2, since 1 minus ln 2 is always greater than 0 because of this condition over here, so this expression is always greater than 0 and this is a constant, we'll have a straight line which is parallel to x-axis and also above the x-axis because y is always positive because our y is greater than 0. And this sign over here should be a not equal to sign, right? So you know that your cos x should never be equal to 1 minus ln 2. And if that's the case, you know that cos x is an alternating function. So this line will always pass through the cos x function over here. So if you calculate the largest interval for which your y function is always defined, it will be definitely inside this interval over here, right? And since we don't want our cos x to be equal to 1 minus ln 2, we'll have to exclude these endpoints as well, and which also clearly satisfies the given condition in the question, that your y function is defined for all x in some open interval. So if this is an open interval, we know that the endpoints are not included in the interval, which is also confirmed by the solution we are approaching to. So that is why if we calculate the largest interval for our y to be defined, it will be in between these 2 points where your L is equal to 1 minus ln 2. So that is why if you'll solve for your x values over here, you'll get x to be not equal to plus minus arc cos 1 minus ln 2, which are clearly these values over here. So in this case, your largest interval would be x less than arc cos 1 minus log 2 and x greater than minus arc cos 1 minus ln 2 in this case. So this will be your largest interval. Log 2 and ln 2 are the same thing. You can change this log 2 as ln 2 as well. So your largest interval for x, where your function is defined, is this interval over here, right? Again, if you have any questions regarding this observation, this interval calculation, feel free to comment down in the comment section below. So that's it for this video. Again, I know that was a tricky problem to solve, but if you know the individual steps on how to break down this question into multiple parts and then solve for those multiple parts, you can easily solve this question by breaking it down into multiple parts rather than calculating the question as a whole thing. So feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.